Hello. So this is chapter 1.1 index laws from the algebraic expressions chapter if you're following Edexcel for A level and AS level maths. This is the first section you encounter in AS level maths. It's quite nice. It's basically a refresh from GCSE, nothing new here. The same index laws you should be used from the GCSE, but towards the end we'll look at a more like advanced style question which you might not see at GCSE. So just to recap, first of all, some notation, which it just means mathematical language or terms that we use. First of all, you need to recognize this sort of expression and that this number A is called the base and this number B is the index, or we sometimes call it the exponent. Okay. And that's what we're going to be looking at. Different ways, different laws, different rules that relate the index of different expressions. And so these laws are, first of all, if we have the same base times with different exponents, what you can in this way, what you can do is just add them together. Because this is essentially saying we times it x a times, so x times x times x, da da da, and this will go for a times. And then we also times in xb times, right? And so in total, this whole product is x times by itself, a and b times. Okay, so that's sort of the whole logic behind that. But that's the rule you need to know. Inversely, we can also divide. So if we have x to the a divided by x to the b, so again the same base with different exponents divided together, you subtract. Okay. Um, and then we can also deal with brackets. So if we have uh, x to the a, so a base with a power raised to another power, you times the powers together. Okay. Because this is like x to the a times by x to the a times by x to the a b times, right? And so that is saying x to the a times b. Okay. Cool. And then the last one, I guess sort of an extension. If you have multiple, um, a multiple terms, so a product inside the bracket, and then all raised to another power, you raise each individual term by the power. Okay. So of a, b, two different numbers, a, b, all raised to the power n, then you basically spread out or distribute the n. So A and B are both individually raised to the power n. Okay, so those are the laws we need to work with. Nothing totally unfamiliar. So you just need to put this into practice. Okay. So look at example one. Let's leave it there. And this is on the textbook. So simplify these following expressions using these laws that we have up here. Okay, so x to the 2 times x to the 5. Well, we add them, right? So that'll be x to the 2 add 5, which would be x to the 7. Cool. Part B, 2r squared times 3r cubed. Now, what this is saying is, firstly, when you got we got terms like this, we multiply everything, right? Because this is saying 2 times r squared times 3 times r cubed. So a common strategy with this, when you got numbers mixed with different terms together, you times the numbers first. So 2 times 3 is 6. Then you times the r squared and the r cubed. Now r squared and r cubed is going to be r2 plus 3, which should be r to the 5, right? It's the same add addition of powers that we did in part A. Okay, cool. Part C, scroll down. We have b to the 7 divided by b to the 4. And again, we're going to subtract the powers, aren't we? So it's going to be b to the 7 minus 4. So that's going to be b cubed. Cool. Part D, we have 6x to the 5 divided by 3x cubed. Now, I think the best way to spot what's going on here is to convert this division into a fraction, right? So 6x to the 5 over 3x cubed, right? In general, it's very helpful to do that. In general, a divided by b is exactly the same as doing a over b. Okay, that's the whole meaning of a fraction, right? So that's all we've done there. Um, and so that makes it a lot easier to see what's going on. Because firstly, again, like we did in part B, let's deal with the numbers, the physical numbers 6 and 3 first. So we first be saying 6 divided by 3, which is going to be 2. Then we can do x to the 5 divided by x cubed. That's going to be x to the 5 minus 3. Remember, you subtract because we're dividing. So 5 minus 3 is going to be 2x to the 2, or 2x squared. Okay. Okay, cool. Part E, um, we have a cubed squared times 2a squared. We're going to need to simplify this bracket thing first, aren't we? So a cubed squared. So write it here as it, for example. Let me get rid of it. I'm going to need to make more room. So a cubed squared, or a to the 3 raised to power 2. We times the powers together, so it's going to be a to the 3 times 2, which is a to the 6. So that's all simplified nicely now. So what happens now is we can now just times everything together. So again, we've got two numbers. We've got a 2, but also this is 1 in front, okay? It's a hidden 1. Remember, if we have 1 lots of something, we just ignore the 1. But what that means is 1 times 2, we still have 2. And then we can times the algebraic terms, the a together, right? So then a to the 6 times a to the 2 is going to be a to the 8, isn't it? If we add 6 and 2. Okay, cool. And then part F, let's do it up here. Now we have 3x squared, which is raised to the power of 3 divided by x to the 4. Again, I think it's a good idea to write that as a fraction. And so then we can divide the power. We can see what to divide, right? But again, like with the part A, we've got this nasty little bracket here. So let's simplify that first of all. Well, 3x squared cubed. Well, what we're going to have to do is, because we've got multiple terms inside, not just an x, but we've got a 3 as well, we raise each part by 3. So we're going to have 3 cubed, and then x to the 2 by 3. Now, because we have a power, we can times together, like with part E here. We have x squared raised to power of 3. It's going to be x squared 2 times 3, isn't it? So 2 times 3 would be x to the 6 over x to the 4. And now we can work this out, because 3 cubed is a physical number we can work out. 3 cubed is 3 times 3 times 3, which is 9 times 3, which is 27. Okay. And then x to the 6 divided by x to the 4, we subtract the powers, so 6 minus 4 will be x squared, and that will be your answer there. Cool, so hopefully that's sort of GCSE level, but hopefully you recognise, and it is important to recognise that where we apply the laws, right? So cool. We can continue with this then to simplify some more stuff. So we can simplify input expressions involving fractions, which will be very important later on in the course, particularly when you look at differentiation and so on. So it's important we can simplify these as well. Okay, cool. So part A, we have x to the 7 plus x to the 4 over x cubed. Well, the problem here is we don't have we can't combine this into one just yet because we have a plus. Okay. So we can't say x to the 7 plus x to the 4 is x to the 11. That is not true. Okay, because we're adding. That would only be true if we were timesing. Okay, but because we're adding, we can't really do anything. Okay, but what we can do is recognize, because we've got a fraction here, we can split this up right into different fractions, which we can work with. So that would be then x to the 7 over x to the 3, add, and then a separate fraction, x to the 4, add x to the 3. And now notice we can apply these index laws. Because now we can say, well, x to the 7 divided by x cubed, well, it's going to be x to the 7, subtract them, to 7 minus 3 will be x to the 4. And then likewise here, the second one, x to the 4 divided by x to the 3, before minus 3, which should be x to the 1. But obviously x to the 1, we can just omit it, right? Because not, like I said, like I talked about earlier, when we have just a 1, we can kind of omit it. And there we are. Cool. And then part B, we have 3x squared minus 6x to the 5 over 2x. Again, we can split the fraction up to make things, to make sure we only have singular terms, which we can work with. So that we can split this up to 3x squared over 2x minus 6x to the 5 over 2x. And now we can work with this. So 3, first of all, divide the numbers, because the physical numbers we've got together. So 3 divided by 2. Well, there's not much we can work with there, unfortunately. So we can just leave it 3 over 2. That's a simplified fraction. Okay, 3 over 2 is simplified. So we're going to say 3 over 2. And then we can deal with the x terms, right? So then x squared over x. Now again, remember what I just said. X is also x to the 1, okay? So a little fact to keep in the back of your mind when you deal with these index questions. If you have an x, that's same as x to the 1, okay? If you need, and so we can use that now because now we can subtract the powers. Because then x to the 2 minus 1, that'll be x to the 1, okay? And then x to the 1 is just x, so we can leave it as there, okay? And then we can deal with this in the second bit. So then, because we've got numbers and x's mixed together, let's deal with the number bit first, like we just did. So first of all, we have the number, so 6 over 2, 6 divided by 2. That does go simplifies to 3, right? 6 divided by 2 is 3. And now let's deal with the x bits. So we have x to the 5 divided by x. Again, that's 1. So 5 minus 1 will be x to the 4. And there we are. Nice. Part C, 20x and 7, add 15x cubed over 5x squared. Again, we can split this fraction up. So 20x and 7 over 5x squared. And then separately, 15x cubed over 5x squared. Again, now with the physical numbers, we could work with that first. So 20 divided by 5 is going to be 4. Cool. And then x to the 7 divided by x squared. Well, 7 minus 2 will be x to the 5. And then with the second bit, again, 15 over 5, 15 divided by 5 would be 3. And then x to the 3 divided by x to the 2, we subtract, so 3 minus 2 will be x to the 1, or just x. Cool. And that's really it, right? Nothing too much from G to C. But I guess we could look at the exercise then in this section, so some more questions. And then we'll leave off with an exam question to finish off the section. Okay, I picked the more sort of different questions, perhaps harder ones, and the ones that have been more important and useful to you as you progress through the course. This one is very important as well when you look at integration. But we can do this now. So slightly more of a step up, but let's have a look what it's saying. So we have y to the half equals x to the third plus 3. Um, Now, these are fractional indices, but you do not need to work with that at the moment. Let's have a look. So y to the half is x to the 1 over 3 plus 3. We want to have an expression for y, okay? Show that y is x to the 2 over 3, add a lots of x to the 1 over 3, add b. A and b are just numbers, right? Don't get freaked out by that. But we need y. Okay, we need to go, so we're going from y to the half to y. how are we going to do that? Well, what you could recognize is we have y to the half. How are we going to get to y? We're going to square it, right? Because then we can use the index law, like we just saw above at the start. A to the b, no, sorry, x to the a, again raised to another power b. We times them together. So that I can be a bit crafty here and say, well, a half times 2 will give me y to the 1, which is just exactly y, right? And that's what we're going to do here. So then y would be this x to the third plus 3 squared, okay? And we can expand this using our index laws. So firstly, recognise when we're squaring, that's the same as the bracket times by itself. And so what we can do here is then expand it, right, using the index laws. We will look at expanding brackets in the next section, although this again is a GCSE skill, so hopefully shouldn't be unfamiliar. But if we were to go ahead, let me get rid of this now. If you were to go ahead with this, well, firstly, you're going to do x to a third times by x to the third. Wow, how are we going to simplify that? Well, it's just index laws again. We're going to add them. So that'll be x to the third add x of a third. And hopefully you recognise that should be 2/3. Okay, so that will go to x 2/3. And that's great. We're off to a good start because it says our answer has to involve x to the 2/3. Okay, now let's deal with the second term then. That is times x to a third plus 3. That's going to be plus 3x to the third. And then I'm going to deal with the 3 times by another x to the third. And then to finish off, we have 3 times 3, which is 9. And that's our expansion. And then we can simplify this because we have x to the 2/3. And then we have a common, we can collect like terms, right? We have x to the third in both of these. So 3 lots of x to the third plus another 3 lots of x to the third. That's going to be 6 lots of x to the thirds. And then plus 9, and that is our answer. And notice this is in this form now, x to the 2/3 plus a, where a would be 6x to the a third, plus b, which is our plus 9. So b would be 9. Cool. So it's fair, hopefully you should start to get comfortable or used to that sort of problem solving style, which should be in the A level. Okay, now let's have a look at this question. So we are told to express 27 to raised to the power 2x plus 1 in the form of 3 to the y. Okay, so we need to somehow get this 27 into 3. Okay, but so then how are we going to do that? And the questions like this, you need to sort of realise how you can express two numbers as powers of each other. So here, 27 and 3, hopefully you should be thinking 3 times 3 is 9, and then 9 times 3 is 27, right? So they go into each other. And so therefore 3 cubed will get us 27. And that's the key thing to realise here. Because now what we can say is we can essentially substitute this result in. Because then 27 is exactly 3 cubed. Put a bracket in, and then that's all raised to the power 2x plus 1. And now we can use our index laws, right? Our indices. Because now, because we have this bracket, and then it's all raised to a power, we can now times the powers together, right? So we're left with 3 to the 3 times 2x plus 1. Remember, it's a bracket times with 3 by everything. And then we expand this out, do the multiplication. So it'd be 3 lots of 3 times 2x, which would be 6x. And 3 times 1, which would be plus 3. And now that's in the form of 3 to the y now, isn't it? And it says to state y in terms of x, well, clearly the indices don't have to be the same. So that means y is 6x add 3. And there we are, that's our result. exam question, which should be a bit of a step up, but hopefully this sort of really reinforces your knowledge of indices that we just covered at the sort of exam level. But let's have a work with it. And as always, I would encourage you to probably perhaps pause it or go over it first if you're learning the topic, and then you can see how we approach it. Cool. So we are given an exam question. It says the curve of equation y is 3 times 2 to the x makes the curve with equation y is 20 minus 2 to the x plus 1 at the point P. Find the x coordinate of P. So a little bit of waffle, but you should know that if two curves cross, we want to equate them together. So what we essentially want to do is to solve for x, where 3 times 2 to the x is equal to 20 minus 2 to the x plus 1. And we need to solve, find using x. Now it's a bit tricky because x is kind of the exponent. You're not too used to having to solve stuff like that. Uh, so how are we going to approach that? Well, we're going to have to use indices then, aren't we? What I noticed right away is 2 to the x is common on both of them. It's a common term. But this is the 2 to the x plus 1 is a little bit different from 2 to the x. But I know I can somehow get there. I know I can somehow convert this into some form of 2 to the x. Well, how are we going to do that then? Well, we should again recognize your index laws and say, well, this is going to be 2 to the x times 2 to the 1, right? Because then if we're splitting this up essentially. And again, this will be a common sort of strategy to approach questions in our later topics as well. So be able to recognize you can split up indices in this way using the index law by adding them together. So we can split this up in this way. And now we'll have 2 to the x. But 2 to the 1, we don't need to worry about because it's just a number, isn't it? This is saying 2 lots of 2 to the x. And so now this boils down to 3 lots of 2 to the x is equal to 20 minus 2 lots of 2 to the x. Okay. And now actually I have a common, it's exactly 2 to the x on both sides. I have one term of x. So now I can probably rearrange to get some sort of solution for x. Um, okay, but it might still be looking a bit fiddly, a bit tricky. But what if now I don't like these times in. So what I'm going to do instead is just make it as a bracket. So 3 lots of 2 to the x is equal to 20 minus 2 lots of 2 to the x, which will make probably visualize what's going on or what to do a bit easier. Okay, well, like with solving equations, a good strategy is to bring all the x's together on one side. So 3 lots of 2 to the x add. So if I add both sides, I get rid of this on here. So then if I add 2 lots of 2 to the x, I then get 20. Okay. And so what you could recognize at this point is I have to say I'm collecting like terms again, aren't I? Because I have 3 lots of 2 to the x and 2 lots of 2 to the x. Um, so in total we have 5 lots of 2 to the x, right? Hopefully you can see that, and that equals 20. Because essentially, if we said u, for example, it's 2 to the x, we're then saying 3u add 2u is 20. And hopefully you can spot if you collect like terms. This is 5u, okay? So we get 5 lots of 2 to the x there, okay? So make sure you can visualize that and what we've done there, okay? Okay, cool. Now, if I want x on its own, so I probably is the best bet to get rid of this 5. So I'm going to divide by 5 to get rid of the coefficient, the number in front. So therefore, simply 2 to the x is 20 over 5. So 2 to the x equals 4. Wow. Now, kind of like the last question, you should be able to spot this solution now. What index of x, what 2 to the something equals 4? Well, you can also simplify this because we know that 4 is 2 squared, right? So this is saying 2 to the x is 2 squared. So therefore, just compare the indices. We then get the solution. X is 2. And there we are. Cool. Um, now, if you go further on in the course, particularly when you look at logarithms, you do look at a more practical, efficient method of solving this. But this, you can solve using indices. I think this is a good test of your index laws. I think this is a good question. But yeah, that's index laws. Hopefully it made sense. But yeah, cool.